Sorry I'm a couple of minutes late. I thought I was on time, but then got sidetracked getting it all ready. We're here to do some index rules today. We're going to make sure that we covered 3 different rules, and there's going to be some more rules tomorrow, which will be for the higher tier. So if you're understanding these and you want to go and look at what the higher tier GCSE rules would be, but for the moment we're going to stick to 3 different rules. I'm going to introduce them, we're going to practice them, probably about 15 to 20 minutes, and then after you've done that there's a worksheet for you to go away and practice them. I hope you're all well. It's hot and stuffy in here. In a second I'm going to open a window, and hopefully we're going to get some learning done today. So good morning to everyone who's joining me for the first time, or good afternoon, I guess, it's just after 12. Let's get cracking. So let's start at the very beginning, which is always a very good place to start, with what powers are. So let's go straight in to where I think I am, and hopefully you can see the title page. And we're going to be looking today at index rules. We're going to look at multiplying powers, dividing powers, and powers of powers. Hopefully all of that will make sense by the end, and you'll understand what's going on. This is what we're going to be covering. Now, some of you might be wondering, what on earth has Aquaman got to do with indices and powers? Well, everything, because Aquaman's powers only work indices. Just a moment's silence for the death of funny jokes. So, we're going to be learning how powers work, how the rules for multiplying and dividing, and then why the rules work, because that to me is important. It's all well and good me saying this is the rule, but then if I do that, lots of you will forget the rule. It's more important that you understand why and what's going on. Okay? So, I'm hoping that you can all see what's going on, hopefully. So don't forget to send me your work. Send me the pictures of you doing the worksheet. Send me pictures of you watching the videos, whatever. Facebook, email, I'd love to see them. I like to see that people are taking part in my lessons and knowing what's going on. So powers. What are powers? Well, this is what I'm saying to you. Y to the power 7 is written is basically y times y times y times y times y times y times y. There's 7 y's you can see there, but it's not the same as 7y. 7y would be y add y add y add y, but we are multiplying, and we describe this not as y with a little 7. We say y to the power of 7, and I need you to all get into the habit of saying to the power of. Okay, so it's y to the power of 7. Just a quick aside while you're just having a look at that. Good morning to Sophie or Josh. Good morning to Harry. Good morning to George. Good morning to Alicia. Good morning, Eddie. Good morning, Nina. And anyone else who joins us later. So y to the power of 7 is written like this. This is important because everything we're going to do today is underpinned by understanding what's going on. Now, when we come to multiply, the first rule we're going to look at is what is y to the power 7 times y to the power 4. And the question could say, leave your answer in terms of why. Because if this was a number, the temptation would be to work out either on a calculator or work it out in longhand what the answer is. I hate the word answer. Lots of students misunderstand what it means. There is no answer here. It's just a simplified version. But in order to understand it, let's build on what I've just said. I just said that y to the power 7 is y times y times y times y times y times y times y. But I can also use the same logic to think that y to the power 4 is y times y times y times y. Now, if anyone is watching this live and is confused by that, please ask me. But hopefully that makes sense. There's 7 y's in the first one and there's 4 in the second one. So if we're multiplying them together, I could write it out like this. I've just put a times in between the two. And hopefully that very act there is enough understanding for everyone to see why the answer must be y to the power 11. Because I've broken it down, shown what it is. Now you could look at this therefore and think, well, the rule itself is just add the powers together. 7 add 4 gives us 11. But I don't want anyone going away from this going, the rules add them. And then I ask you in a week's time, how'd you do it? Was it add? Was it? There shouldn't be any questioning. So this is the understanding you can do to make sure that you get it right first time, every time. Now, with that in mind, let me quickly move over to my other whiteboard and we'll do a couple of examples where I'll give you a chance in the live chat to have a go. You're absolutely right. 7y means 7 times y, Sophie or Josh. But, so let me have a quick, just ask the question. So 7y means 7 times y, but that is y add y, add y, add y, add y, add y, add y. There's 7 y's there. 7 of them. If we add them all together, there's 7. Y to the power 7 is y times y times y 7 times. So it's timesing itself 7 times. They are slightly different. They are two different things. That is different from that. Okay, and that's quite important. Now what we're going to do, I'm going to have a quick question to see what people are doing. So we've got, what would we get? I'm going to change it to now to m. M to the power 5 times m to the power 2. G to the power 4 times g to the power 6. And f to the power 2 times f to the power 3. Come up with your answers for those. I'm going to give you about 10 minutes. I don't know whether you're Sophie or Josh. I'm going to continue calling you Sophie, Josh. Why is it not 7 times add 4x, not 7 times 4x? I don't know what your question is. Why is it not add? Well, because the question isn't add. The question we were given, if I quickly whiz back to here, the question said, what is 7 y to the power 7 times y to the power 4? There's no add in there. So that's why I based everything on what the question was, not just guessing. It was all based on what the question was asking us. And I can come back here. So these questions, I've got times. So it's not because maths, Nina, that's not as helpful. You're trying to be helpful, which is very good. But just because maths is not some mystery magical world where things don't make sense. It is all logic. It is all basic and can be stepped through. We just have to calmly and patiently understand where people are trying to understand where people are confused and try and explain it to them. So in this one, what I would hope you would all do is write them out fully while you're doing the question. Because if you write them out fully, that while you're first learning will make it much easier. So this is there are 5 of them there, m to the power 5, and then there's 2 here, and you may even decide while you're learning just to put a different colour in between, and I think that makes the answer m to the power 7. Once you start getting to grips with the rules, you're going to then be able to just go, oh, we'll just add the powers. But while you're doing it, because if you just said the answer was m to the power 7, which is fine, I would then, my first question to you would be why. So, for example, when Eddie wrote the answer m to the power 7, my first response to Eddie would be why. Or when you write, so in the next one, Eddie has written g to the power 10. He is correct, but my first question is why. He might turn around and he might say because we add the powers, but it's even better explanation if he says, well, the first one is g times g times g times g. And the second one is g times g times g times g times g times g. And we'll put a purple one in between. That's his reasoning because we're timesing them together. When we're multiplying like that, we're timesing the powers. We're timesing a group of 4 of them by a group of 6, so we just run them all together and get g to the power 10. So a lot of you have got f to the power 5. Let's just check that one. You've got f times f, and you've got f times f times f. Sorry if you can hear lots of plates rattling. I think it's dishwasher unloading time at the moment in my house. So that's why we can hear lots of plates and things being undone. It's my fault for not closing my office door. F to the power 5. So that is where f to the power 5 comes from. I like people saying I get it now. I can see lots of you having a go at these and having quite a lot of success. If you're stuck, feel free to go back and try again. There's no shame in that. No shame at all in going back and trying these again. So this is the timesing. Now let's go back into the studio. We've also got a baby crying. I need to, once the video's over, I need to go and help with that as well. So looking on to the next one. What is y to the power 7 divided by y to the power 4? You feel, see, I'm building the entire thing around this y to the power 7 and y to the power 4. Well, let's look at the same idea. Well, we've already done this. Y to the power 7 is this. And y to the power 4 is this. But in algebra, divide is a fraction. So I'm going to put a fraction in between. And one of the good things you can do with fractions is cancel, as long as you're cancelling the same thing on the top and bottom by times. You can't cancel things if they're added. So if this was y add y and y on the bottom, you would not be allowed to cancel. But as long as everything's times together, you can cancel to simplify. So that's what I've done below, look. I have cancelled 4 of the y's on the top with 4 of the y's on the bottom. I'm allowed to do that because everything's times. There's no adding or taking away involved. So because it's all times, I can just cross out the same number from the top as the bottom, which is my reasoning for why the answer is y to the power 3. Now, the rule itself can be described as when you divide, you take away the powers. But that rule does not explain why. If you then said, oh, the answer is y to the power 3, I would then instantly say to you, why? You need to be able to explain by drawing a diagram like this, drawing it out, and show why it's y to the power 3. That's really important. Thank you, Eddie and Sophie, for showing me why, or Josh, for showing me why it is what it is. Okay? Sorry, for explaining that you understand it now, because it's really helpful to me as a teacher to know which students are getting there and getting it. So it's really useful. All of you are doing really well today. So let's go back and do some divide practice. So I will start a new page. This time we're going to do what is, in fact, what would be really cool is just we do the same questions but change them to divide, simply because if we do that, I think it means that there's an element of continuity. So I think it's possible to draw a net around all of these, capture them all, and delete them all, and they've all gone. I'm going to change it to divide, and the only thing I'm going to do, I am going to make that 14. So there's the 3 questions for you to do. Remember, explain your reasoning. You can put your answers. If you've done, Sophie, if you've done times and divide, there is no rule for add and subtract. So while people are working this out, this y to the power 4 add, there is no rule. You cannot do anything clever with them. It's just, this is its simplest form. That would not simplify. And I'm going to write DNS, which means does not simplify. Does not simplify. There is no rules at all for adding, only for timesing and dividing. Oh, thank you so much, Eddie. That was really helpful because I had the questions and I didn't flip to the right thing. Thank you, Eddie. That's really helpful. Hopefully now you can see I'm on the right page. I was doing so well. Everyone, I thought there were lessons continuing. Everyone knows what they're doing. It was all going well. But now we've got that, and I've been talking while I've been on the wrong page the whole time. Okay, so there's no rule for adding and no rule for taking away, but there is a rule now for dividing, and that's what we're going to do. I'll do the first one with you. Some of you will already have an answer. Remember, we can do the answer by taking away. 5 take away 2. You could just do m is 5 take away 2 is m to the power 3. But my reasoning, if I said y, is because that's m times m times m times m times m, all divided by m times m. So I'm going to cross 2 of those out with 2 of those. So the answer is m to the power 3. Remember, I hate the word answer. I'm going to correct myself and say, so the simplified version is m to the power 3. And for the other two, we're just going to do g to the power 14 minus 6 is g to the power 8. And f to the power 2 minus 3. Remember to do it in the right order. This is actually f to the power minus 1. Well, this leads on to the stuff we're going to do in the higher next week, but tomorrow. But I'm just going to briefly mention it. It's because it's f times f on the top, f times f times f on the bottom. Those two cancel with those two, and it leaves us with just 1 over f. And that is how we write 1 over f. F to the minus 1 is written as 1 over f. So there you go. You've learned something bonus that I wasn't even going to teach you today, but it's because it makes sense to follow on. Finally, the bit I'm going to do on, just checking for any questions, the bit I'm going to do now for raising a power to a power, it sounds more complicated than it is, because this is all it's saying. What do I get if I've got, oh, I don't want to use highlighter, t to the power 2 to the power of 3. Well, we already know that a power means times itself. So this means t to the 2 times t to the 2 times t to the 2. Because we've got three lots of them times by themselves. But we already know that the brackets are t times t times t times t times t times t. Now look what happens if I rub all these brackets out because they're not needed. We get t to the power 6. That's where this comes from. T to the power 2 to... So if we've got a power to a power, how can you get 6 from a 2 and a 3? Well, it's just times. We could have just done t to the power 2 times 3. When you've got a bracket where it's raising a power to a new power, so we've got one power here and one power outside, raising a power to a power, we times the powers together. But I've explained to you why. That's why I'm showing you these. Showed you the long way round. Again, 3 questions for you to do. M to the power 2 to the power 5. Q to the power 3 to the power 4. And B to the power 9 to the power 2. Have a go at those. Give you a few seconds. Feel free again to pause the video to see if you want to have a go at these before I tell you. But because I've told you the rule in here is that you times them together when they're raising a power to a power. The not answers, Mr. Harris is going to stick to this. The simplified version is this is m to the power 10 because it's 2 times 5. This is q to the power 12 because it's 3 times 4. And this is b to the power 18 because it's 9 times 2. However, if I say to you on any of them, but why, you can then say, well, this one is actually m to the power 2 times 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 m to the power 2. There's 5 of them, and that one is m times m, 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 and that one is m times m. Therefore, if we run them all together, that is the reason why it's m to the power 10. So hopefully I've gone the long way round and the short way round. Who said, so what's your question? Oh, I thought it was 5 times 4. Yeah, I may have, my writing may need to be a bit neater on the Q one. Sorry, that's a 3. Okay. It's just not very neat writing. Hopefully that makes sense to everyone. So these are the 3 rules I've introduced today. I have talked to you about the 3 laws of indices. If we go back and just look at me for a second, the 3 rules are when you multiply 2 indices of the same thing, you add the powers. When you divide, you subtract the second one from the first one. Not the biggest from the smallest, but the second one from the first one. The third thing is if you've got a power raised to another power, you times the 2 powers together. However, I've also shown you the reasons why, and I think it's excellent practice when you go away and practice this today, and I hope that people use my videos and then go and do the practice, because if you don't do the practice I line up, number one, I'm wasting my time coming up finding worksheets for you to do, but you're not going to make it permanent. It'll just be a thing that's instantly forgotten. For example, there are a whole series on Netflix I've watched the series of, I then can't remember I can watch them back. I'm currently watching Heroes again, which I watched 10 years ago. The reason I can't remember some of the plot lines is because I didn't revise it. I didn't make notes. I didn't practice and go, oh, I've got to remember this, got to remember this. Because I was watching it for entertainment. This lesson, hopefully, is not just about entertaining you. It's about also teaching you maths. And practice makes permanent. So that's why I'm requesting all of you consider going into the description, click on the link on the Index Laws worksheet and work through it. Complete all the questions, then look at the answers and see if you got them right. I've also got an ongoing Taskmaster challenge, a 2-week one. This one because people will need. It's a bit bigger challenge. Design the best and most incredible water park. Maybe you don't want to draw it. Some people have said they're not going to draw. Use Lego and build one, or build one in your garden. I've got a pond. I'd love to make a little water park near my pond. I might do that this afternoon. That might be going in the garden, get some Lego figures, and make a little water park. That sounds amazing. So I've got frogs in there as well. So I have to be careful the frogs don't eat the Lego men. I hope that's made sense to you. I have done my best to make it accessible to everyone. If you've got any questions, put them in the comments below. I've been Mr. Harris. You haven't. Feel free to always ask me any questions you have. Look after yourselves, and I'll speak to some people tomorrow. Bye-bye.